Right. Okay. So, hello, and thanks for bearing with me while I sort out this. But yeah, sorry. So I'm Stephen Strachan. I work with Changeworks and the consultancy team, which is within our technical directorate. I personally work across all aspects of an energy system. I have a specific for decarbonisation through holistic approaches and improving our existing infrastructure. So what I want to talk about is just a brief about Changeworks and who we are. So we are Scotland's leading environmental charity. We have a specific vision, which is all part of our strategic plan, which is a world where people are able to live, work and enjoy life with a low carbon impact, and a mission to develop and deliver high impact solutions to make low carbon life a positive reality for everyone. So really, within our technical director, our focus is on the delivery. So we develop and manage innovative pilot projects and support the development and delivery of energy strategies such as local heat and energy efficiency strategies and the pilot phases for Scottish Government and local authorities. And we roll out heat SABs programs on behalf of local authorities. So why are we talking about heat networks? Why is there a focus on heat networks? Well, it's quite simply, the last few years, the UK and Scottish governments have been setting ambitious targets for the decarbonisation of heat, which is 40% of our carbon emissions. They see low carbon heat networks as one of the key methods of delivery alongside electrification of heat with heat pumps, and in some, excuse the pun, cases, the pipe dream of using hydrogen and or green gas. Both governments are developing heat network bills and regulations around the operation and management of heat networks, with Scotland's draft being published earlier this year. If you haven't read it, the proposed bill will see councils responsible for zoning areas for heat networks, and part of their local heat and energy efficiency strategy will identify those areas, and then also the heat network owners and operators requiring a license. There are still questions to be answered on minimal technical and performance standards. So potentially in line with the CIBSE Code of Practice for heat networks with regards to technical standards, and consumer protection, which has so far only been voluntary through the Heat Trust, which is a voluntary scheme. There's also about a lack of clarity on whether existing heat networks will be subject to the same regulation, but I would suggest that it's likely that there will be some regulation around for existing heat networks, and so it may be a case where those owners and operators of the smaller systems or larger systems at the moment need to make changes in order to adhere to those regulations. I think it's worth considering when we look at heat networks, what is the heat network and what is it to you? What is it to the owners and operators of heat networks? It usually falls on the responsibility of an asset manager if it's within a housing association or a local authority. So it's just worth having a real think about what an asset really is, and I think it's that key wording when you look at in the is what an asset is. It's a useful or valuable thing or person. It's something which actually provides a positive resource to the owner. So the question is that if you own or if you operate or if you know of heat networks, how many of them would you count as an asset, and does it provide a valuable function, and is that economically, environmentally, and for the heat customers, does it achieve its initial aims and objectives? Is it an asset, or is it more of a bit of a millstone? So what we've done is we've done quite a lot of research in the past and continue to do on heat networks. And what we found, and what we usually find, is that a couple of things is that, first of all, the primary motivations, particularly for housing associations and local authorities to develop a heat network, is carbon reduction and fuel poverty alleviation. And there's an assumption that it would be economically sustainable. I think a lot of the time when they see feasibility work done, it always stacks up. But there's little detail in the feasibility studies that show what needs to happen for it to stack up economically, and then therefore achieve those initial aims. However, when we speak with, and I've worked a lot with housing associations, local authorities on their heat networks, through the research and through work ongoing, we find that a lot of the time the performance is anecdotal evidence with the assumption that they're actually not viable economically. So it goes from the feasibility stage of economically viable, achieve the key aims and objectives, to when it's during delivery, when it's actually in and it's installed, and a couple of years later, there's an assumption it's not viable economically. So we get comments such as, "Oh, it's working well. No one's complained for a few months. Everything's okay. How well is the system performing? Minimal complaints." Isn't really a basis for actually analyzing the system performance. So the question is also when I speak to the operators, again, I've had comments and quotes saying things like, it costs money to have a heat network. Heat networks cost money, but it's okay because it still costs less money than maintaining 200 gas boilers because of the access restrictions and so on. And again, it always surprises me is how you can have something where even if it's a basic gas boiler system into a heat network, how you can buy commercial gas at 1.7, 1.8 pence per kilowatt hour, charging heat at 4, 5, 6 pence a kilowatt hour, and the system still makes a loss. Where's that coming from, and why is that not being identified? So, slide too far, sorry. So a big thing here is by keeping Mr. and Mrs. Jones happy at number 23, and knowing having complained for a few months, we've been prioritizing guaranteed comfort over performance. So the scene on the screen there is something I see far more often than I would ever care to, and it's the flow temperature of the network on the left and return on the right, with just a few degrees between them. Borrowing an analogy I heard a few years ago, it's like filling up a tanker in Edinburgh, driving to London to drop off a few litres, and then driving back up to Edinburgh with nearly a full load. It's essentially sending heat out onto the network in case it's required, rather than adapting to the actual heat requirement, the actual load. Yes, it means that no customers are complaining. Heat customers are toasty warm. Mr. and Mrs. Jones are roasting. And whoever set up and looks after the system has been is achieving what they've been asked to do quite critically, as they've been told to make sure it heats, make sure it provides the heat, that service of heat. So they've done that. They've set it up to make sure it's done. But it is the most obvious sign of a poorly performing heat network. So again, I say this, if you have a network and it looks anything like this, then I would suggest it has to be looked at in a bit more detail. So why is it important? Why is efficiency so important? And quite simply, it cannot achieve its core aims if it's not an efficient system. When heat is lost on a network, someone has to pay for it, of which there are only a handful of options. It's either charge more for the heat cost, so suddenly it's then no longer achieving the fuel poverty aim and objective, or alleviation of fuel poverty. You could subsidize the heat charge, but again, all that happens there is that any outgoings to the heat network owner and operator, if it's a registered social landlord, it will end up being charged to the tenants through rent costs. So again, you're moving the fuel poverty into just poverty. It doesn't really make a huge amount of difference where they're paying for it. The tenants are still potentially paying for it. Or you can look to address the issue and find out why it's performing poorly, why it's not making any money, simply, and what can be done to improve that. For me personally, it's almost more concerning on the low carbon side, is that if you have replaced a traditional heating system, such a retrofit, or if you decided to go for a heat network instead of a more traditional option, then the heat network, when performing poorly, could end up, and in a lot of cases I've seen, is more carbon intensive than that equivalent system. So I've seen heat networks with CHP units, CHP engines and gas boiler backup and so on running at a low enough efficiency that they would have been better environmentally, economically, to have just fitted the gas boilers in the first place. So then we need to see what's the motivation for putting in the heat network in the first place if it's not going to run a level of efficiency high enough to actually achieve those core aims and objectives. Another problem is that these poorly performing systems become a bad news story, of which we've all heard them, and it undermines confidence in heat networks, but it also it then makes it harder to convince for investment to update and improve the scheme. If it's almost written off from day one as being an inefficient, waste of time, we have to subsidise tenants' charges, and we assume it loses money, and it loses money, but it's okay. It's still less than maintaining 200 gas boilers. So how do we fix it? What do we have to do to try and reduce these problems? And the first step is to try and find out the root of the problem. And it's really important at this stage to point out that poor performance isn't just technical and plant issues. The operation and the management of the heat network is absolutely key to performance. So what we do at Changeworks, and what it's worthwhile looking at doing yourselves if you own or operate the network, is to do a full assessment. So you start off through this assess and refine, repair, and then manage. So the initial assessment is looking at any data that's available. It's doing interviews to try and work out and build a model of what the current operational and management structure looks like. So we can see if there are any gaps that need to be filled or where any problems have lied there. And then it's about refining. So in some cases, it could just be a little change in things, a few changes in settings. You've got a perfectly technically suitable network. It's just not been managed correctly. So we look at how it's managed and put a plan in place, a strategy in place to manage that and refine the existing system. Then you look at repair, and this is a difficult one because it does mean that there is potentially more investment on something which may well have gone over budget in the first place, which is then underperformed since its installation date. So it's hard to release additional capital to improve a system which was meant to be correct in the first place. Very difficult in some cases to get that through finance directors and so on, but essential in order to smooth out that curve of losses as we go on. And then the same thing with the strategy, the operational structure. We look at trying to build that, repairing that, moving away from things, and potentially outsourcing certain elements of it if required, if there isn't enough in-house expertise to do so. And then the onward managing, that clear forward-thinking strategy. Everyone knows the role, everyone knows the responsibility, and everyone is able to achieve that at their highest ability in order to then maintain that efficiency, as well as looking at what strategy is going to be in place for upgrading and improving the network. Because I think a lot of the time that we're still quite guilty when looking at developing heat networks of fitting a gas CHP system and not necessarily during installation phase countering in the increased plant size and so on that you might need for putting in an additional technology, a heat pump or something further down the line. What is the strategy in place for continually upgrading and improving that heat network? So looking at a couple of case studies, ones that we've done in the past. The first one here is a small heat network in Dumfries in Galloway. It's a small biomass system. It only does 11 properties, but it's very typical of sort of rural housing association type systems where there was funding available for this. It became a condition of the build of a small new build development to look at biomass as the heat source, and then it was a great example of a lack of understanding from the initial procurement team. And I hasten to add that the support from the funding body. The specification was too wide and resulted in installation of essentially a completely unsuitable plant and controls. Overall efficiency is very poor, so sub 40%. And again, we see that flow temperature and return temperature as a key indicator of poor system performance as soon as you walk into the plant room up on the control screen. So again, they were desperate to fill a full tanker to London and drive back up the road again, with most of it left. So in this case study, in order to resolve the problems, there are some things that we couldn't change. So some things you aren't ever able to change, such as the diversity. And diversity, being for anyone that's unfamiliar with that phrase, is essentially the balance of demand over the numbers of dwellings. So in some cases, you walk in and see that the boiler may well be far too big. It's oversized because you don't ever need to provide heating and hot water exactly at the same time, particularly with instantaneous hot water systems. So it's more about sizing a smaller boiler to cover 80–90% of the annual load, and then backup systems in place. In this particular project, because there was only a small amount of properties, it wouldn't have made a huge amount of difference anyway, but it's something to bear in mind that when looking at alterations, we sometimes can't change that. Can't change the location, it is where it is, and you can't change the heat loads when we're looking at an existing project, so we just have to look at what we can. And in this case, the only real solution moving forward was replacement of the boiler and replacement of the controls in order to manage that flow and return temperature, and to manage the boiler a bit better. However, as we were saying before, that did result in trying to convince finance directors that there was a difficult decision to make, an additional spend to replace the primary plant and controls, but it does mean that network is then no longer losing money and will be generating a return. So the overall lifetime spend is reduced, carbon saved, and the low heat cost can be justified economically, therefore meeting the initial aims of the network. It's still a biomass system, but it's something which is suitable for that location. It is commonplace, this type of situation, and we do have to acknowledge that signing off on investment to improve the performance of an already expensive heat network that has lost the confidence of the owner is a hard sell, but in some cases it is absolutely necessary. Again, as long as a poorly performing network continues to perform poorly, the overall picture at the end of it looks even worse. And in this case, we're able to then take an underperforming system where the heat costs were massively subsidized and turn it into an efficient system. Again, through additional spend, but it's better than continuing to just lose money as it goes on. So the second case study I'll show you was a larger network, and again, very typical of what we see through the social housing sector in Scotland and in the UK. It was a purpose-built development of 87 flats in Glasgow, with gas CHP and then gas boilers as backup as the primary. So gas CHP is the primary heat generation and gas backup. Gas boiler backup to support it. The staff were very much under the impression in this one that it was rooted in technical issues, and they'd actually gone to the trouble of having thermal imaging of the underground pipe routes and detailed inspection of the internal pipework, picking up on very small sections of uninsulated risers and an orange blob on a picture of the ground, and thinking that was where the performance issues arose from. Again, across the year, average of 49% efficiency, so particularly poor in the summer, of course. As with any heat network, the efficiency does vary throughout the year. So essentially, sorry, I'm on the right slide. The problem, based on our assessment and based on the sort of in-depth assessment of the system and the structure, it was actually linked entirely to the operation and management of the system. The technical components weren't the cause. They were actually specified well and sized well. It was a perfectly adequate system for what it was attempted to do. It's just it had not been looked after. And so the backup gas boilers had actually become the primary heat source, with the low carbon element with the CHP engine was just a passenger. It was sitting in standby. It required looking after and hadn't been done. Again, this is a very common scene. I see it often where a small housing association, or even a larger housing association, or a local authority, they have no experience of being an energy supplier, and they're now responsible for a heat network, but have no experience of how to manage or to operate. And that again, they're not to blame. A lot of the time, the funding bodies and so on will provide the funding, the installation is done, it ticks a box with regards to carbon reduction and achieving minimum efficiency standards, and then they walk away and they leave the housing association or local authority with this legacy of a heat network which is inefficient. They subsidize the heat costs, and they continually think that there's problems with it when it is just looking after it that they have no experience in doing. It's not their fault, but it does need to be addressed. it's very different for a housing association to take on something like this when they are very used to just being responsible of making sure a gas boiler or storage heaters work. As long as they work, it's then up to the tenant entirely to organise their own, paying their own fuel bills and who they get the supply from and so on. As soon as they then become a supplier, it's a very difficult world for them to get into, where they're just, and even looking after the boilers and so on, it's there was a lack of understanding of what was required to look after them. So, the housing association, they see gas boilers and then they employ a gas engineer to maintain those gas boilers. But the gas engineer maybe doesn't have the experience of running a heat network, which is very, very different to maintaining a gas boiler, where the gas boiler comes on and operates at 90% efficiency when it burns or not, has only a small relevance to the operational efficiency of the whole network. And so although they thought the system was being maintained, just the gas boilers were being maintained, leaving the CHP and so on. And again, the same thing had happened there, where they had requested that the gas engineer who was maintaining the boilers was responsible for making sure that all of the properties get heat. So the gas engineers then gone in and altered the settings to just make sure that flow and return is the flow temperature is as high as it can go, and the pump is on, the heat network primary pump is on continually. And so again, we had the same problem with flow and return going down to London, coming back again full load continually on a system where the primary heat source was not operational. So all of this then just leads to that lack of understanding of the roles and responsibilities. So the unsuitable maintenance contract, as well as potentially unsuitable metering and billing contract as well, resulting in essentially the metering and billing supplier being paid a percentage of heat costs, which is quite common, but it doesn't then give any incentive for them to be aware of or to potentially improve the system performance. So the primary lesson on this one is that outsourcing is okay. We can outsource. Sometimes support is required to procure the right contractor, and a lot of the time support is required to procure the right contractor with the right contract. So again, if you're looking at outsourcing maintenance, metering and billing, MMB contracts, it can be a good approach, but it really needs to be set with parameters on system efficiency and not just based on percentage of heat sales and so on. You want to really push the contractors to ensure performance is as standard, and that it's up to them to maintain that performance. There's also elements in there as well when you can look at the metering and billing side, being able to report back on higher users or lower users of energy in order to report that back to the housing association, particularly within social housing projects. There is always the risk of vulnerable tenants, and if this is something flagging a vulnerable tenant or a tenant which is not using the system as well as they could do, then again it's something which goes to a housing officer to be, or a tenant liaison, to engage with the tenant and to improve that. And again, in doing so, it will have an impact on the performance of the whole system, and improving that so slightly. So it's really, from me, the kind of key message is that we want the heat networks to be an asset. We want to change these underperforming systems where they exist, of which there are far more than I ever hoped there would be, and we want to turn them back into an asset and away from a bit of a millstone, which is costing money and headaches and a pain. So again, from ours, and why Changeworks want to be involved in this, is that as part of our vision for a world where people are able to live and work and enjoy life with a low carbon impact, we want to help people enjoy that low carbon life, and getting the best from existing heat networks, we can make it happen, ideally without the householders even noticing. Sometimes small changes to the structure of the management and operation of a scheme, or small technical changes to a scheme, can make as much of an impact as insulating multiple properties, because the heat network is addressing sometimes hundreds of properties. And so a slight change in that is a change to all of those properties' efficiency and their overall individual carbon impact. So yeah, that's that's me. I think it'll be good to hear from you and any thoughts that you've got, and again, just get some questions. It'd be great. Thank you.
Many thanks, Stephen. Appreciate that. That was great stuff. Yeah, no, some very interesting takeaways there. I think it's really important to be aware of the legislation as it is coming down the road, how that's going to have an impact. And I think it's incumbent on us within the industry to just pay attention to that and be as participative members as possible. Also, I mean, I really, it certainly chimes this idea of the idea as treating these heat networks as an asset, and getting them on board. What were your thoughts, Alistair?
I think Stephen's absolutely right. The biggest issue tends to be that these systems are not maintained as they should be. I wouldn't use the word poorly maintained. I would say that there really isn't, and there's a lack of effective maintenance regime in place, and the contractors that are doing this maintenance are typically domestic engineers working on what we would call a commercial system. And I think that's the heart of the problem, is understanding that just because it's in houses, it's not a domestic system, it's commercial.
Absolutely. Yeah, and it's also, like I say, it's not the fault of those that own and operate the system.
No.
It's just a lack of understanding, and it's about sort of upskilling them to understand what is required in order to maintain it properly.
Yeah, agreed. Yeah, so I think that's the key. The key take on this is you can build a brilliant heat network. You can design it. You can acceptance test it to get it over the line. But it's what happens afterwards. It's about it's basically interrogating the maintenance regime, making sure they have adequate training on the product, that there is a checking going on that says that they really should be doing this kind of job. But it's nobody's fault other than the regime and somebody who knows what they're on about actually interrogating that regime.
Absolutely, yeah.
I mean, in terms of both of your experiences, in terms of approaching, we are essentially talking about existing heat networks here, but there's clearly some interesting lessons to be learned, or things to be taken on board when developing new build as well. But with respect to the retrofit, what have been your experiences with respect to the appetite for making those changes when you've got the existing heat networks that have got some kind of issue with them?
Do you want to kick off with that, Stephen?
Yeah, I think that. So I think for people, when they have a heat network that they know is not performing as well, then there is an appetite. But I do think there's still a lack of clarity across some organizations of how well the system is performing. So, financially they will see it makes a loss, but maybe only with the finance team, and that's not then fed down to the asset manager, because his responsibility or her responsibility is entirely to make sure that the people are being heated and the tenants are achieving what they need to achieve. So if they were aware of the performance, the real-time performance across departments, then there would be more of an appetite. But it's also difficult as well, and again, as I mentioned, is that a lot of it is the perception of a system which has already cost a lot of money, which has already caused a lot of pain and heartache almost, is then spending more money on it to upgrade it. That's a very difficult thing to get into people's heads, that needs to happen.
Agreed. Yeah, I totally agree with you. I think the appetite is there. So I do, as a heat network consultant, I get involved in surveying these legacy projects quite a lot. And I'll, in the winter, regularly go to a project at -2 and see 80% of the doors or windows open, even patio doors open. Communal areas, no controls on radiators, no thermal temperature control, aging plant. And typically I'll go back to the client, present my findings to them, and then turn it into pound notes and say, look, you're a housing association, you're currently supplying this with heat with rent. The end tenant is essentially paying for this within there. If you if you truly believe in what's on your web page about, you know, social responsibility, fuel poverty, then you need to do something about it, because using 25,000 kilowatt hours of gas in a 2-bedroom flat is just not on. You're delivering 3,000 and you are losing the rest in the distribution and mismanagement, poorly maintained system. So the appetite's there. The difficulty is that when you bring that to the table, it scares a lot of people, and you know, and with all due respect, some people bury their heads in the sand then and you never hear another thing back. What you really want is for a few simple steps, costed steps, things like presettable radiator valves within the flat, temperature control within the flat. You can actually control this hierarchy of heat better. It's low cost to high cost. The plant room is typically the last thing to look at. It's what's happening in the flat that is really the driver, and you can make an impact without too much cost.
Yeah.
Okay. Well, I have to say, if there's any questions, please let us know. But it seems that there's nothing coming from the floor, as it were, at this stage. You know, what's the first step? What's the very first step that you guys would recommend? You know, to, you know, because I think what you're talking about, what I'm getting is that there's the financial time, energy piece, which of course we all have to cope with, is a big barrier. What could someone do and half an hour later feel good about themselves and say, yeah, I figured something out here, or I can improve it? Or
I think Stephen hit the nail on the head earlier on that slide where he came up with data analysis. If you can't measure what you are using, you cannot control it. You cannot hope to have an impact. So you need a review of your system, and that can be done remotely via numbers. So list of heat networks, what the current gas usage is, or energy usage overall, not per flat, and then you divide it by the amount of flats. And then if you are getting, you know, above 10,000 kilowatt hours per flat, you know you've got major grief.
Yeah,
you should be between 3 and 6 typically. I have projects where I have, believe it or not, 47,000 kilowatt hours of gas per flat. So quickly you can address and assess and pull out these projects that are really giving you headaches. Look at your delta T's, your temperature difference on your plant room, and look at how you are controlling things in your flat. Pretty much in that order, you can quickly work out the real ones that need your urgent attention.
Good. Anything to add on that one, Stephen?
I think also on the management side, I think it's worth just taking a glance at who's responsible for what. Are all those roles and responsibilities filled? Who is it that looks after it? Who is meant to be aware of performance? Because surely if you have a heat network, in a lot of cases a very expensive heat network, someone should know how well that's performing. It should be within their job role.
Actually, just referring to the regulations, so you've got heat network regulations. Maybe just, is there one or two contraventions of the regulations that you see quite often and that could be easily remedied, or do you find that most people are up to speed with heat network regulations? What would you say? So I mean, I think because that's your base level, isn't it? What we talk about is aspirational compared to that.
There are rules, Ben. There are the heat network metering and billing regs 2014 state that it is a legal obligation of every heat network operator to report on the performance of their heat network every 4 years. So by Christmas this year, every heat network that was put in before December 2016 should have been reported on. Nobody does it because the vast majority can't, because their metering and billing system cannot provide that information. So we, between us, need to audit these systems as an industry to make them fit for purpose so that they can be reported on. But it's rare. But that will be pushed even harder with the appendix to the regs coming out later this year.
And, you know, as an incentive, if you do put in the right metering and billing, obviously you've got the management piece, but, you know, you'll actually be able to improve your revenue as well, won't you?
Yeah.
You will.
You need that system efficiency, the overall system efficiency, in order to achieve that economic aim of it at absolute very least washing its own face, but it really should be. I still can't quite comprehend when we have heat networks where you're buying fuel for less than 2 pence a kilowatt hour, and it's charged out between 4 and 6 pence, and the system loses money. It astounds me that that still happens, and that someone hasn't gone, hold on, why? Let's fix it quickly. Every day we're losing money.
Yeah. Okay, guys. Well, is there anything else you guys, any other points or questions you'd like to ask each other?
No, I don't think at the moment. I think it's more of a case that I think between us we've hit the nail on the head that you need to look at these things as almost a living, breathing entity. The biggest issue we have is where different companies are responsible for different parts of the maintenance, different parts of the install, different parts of the commissioning. And there's really nobody standing back and going, how is this heat network performing? Is it performing as the design, as per the client's brief? If it's not, what is the issue? Is it maintenance? Is it technical issues? Is it simple, temperature control? But unless you can assess it, and the difficulty is there aren't that many people out there that can do that role and look at the whole network and go, your CHP machine is switched off because you have too high a return temperature, because you have no control in the flat. Let's put control in the flat, and guess what? Your CHP will now come on. But there isn't that knowledge out there, I'm afraid, to assess these networks as a living, breathing thing. So you get a gas engineer doing the gas boiler, you get a service engineer servicing the HOU, and none of them ever communicate.
No, and it's also for new developments. I think if there's anyone listening that's looking at developing new projects, it is at that procurement stage where it's absolutely critical to get those responsibilities ironed out and to get the minimum specification required, because a lot of the time, particularly on social housing developments that I've seen, it's a design and build contract, of which then the heating side has been subcontracted out by the main contractor, and the only guide is that it's a heat network with a CHP engine. It has to be a CHP engine, gas boiler backup, and that's it. There's no specification on flow and return temperatures. There's no specification on anything, And so then they will do it as easily as they possibly can. That is the joy of construction. And if you ever work in construction, is that you know that if you get a brief, you will do it to what you're required to do and no more. Why would you? So then there then has to be an understanding that if you are looking to procure someone to design, develop a heat network, where do you get support? You need support to make sure that you're procuring the right thing. And that's something which you have to go out and potentially procure a consultant to support you to make sure that you're procuring the correct network design. It's also a thing as well, I'd say just quickly, is that there's also an understanding, and it's a difficult thing with heat networks in particular, where the owner of the properties, the owner of the flats, the buildings, the houses, feels that it has to be their heat network. Whereas in reality, there might be a better solution, as you see on the continent, you see in Scandinavia, where you invite a third party in who is a heat network developer by trade. That's what they do. And they then own a percentage or all of or half of or whatever the heat network. Then you absolutely ensure the system is designed for efficiency, because it's up to them to make sure that it's efficient, and they will make it efficient, because an inefficient system won't bring them a return. It has to be efficient. So you're using the fact that economically it needs to be to a certain level of performance to your advantage by bringing in a third party to be responsible for the whole heat network. Or you contract a heat network manager on your retrofit, your existing heat network, to achieve minimum efficiency standards. Otherwise, they don't get paid. So it's contracting, correct contracting, and knowing what you're going to do.
I think that's absolutely spot on. I noticed that the client police officer role is rarely filled. In that the D&B will go out to the main contractor, and the client will be left to deal with the main contractor. I as a mechanical consultant, do the acceptance testing and get involved in checking the on-site work. And where there is nobody sitting between the client and the main contractor, it really is difficult, because the client, there's nobody really holding on to the beliefs of what the client's design brief was in the beginning and what it means to the tenants. So unless you get your new heat network acceptance tested or your retrofit heat network acceptance tested, where somebody comes in on behalf of the client and reviews the whole system to CPSI code W and has those difficult questions. Why have you done that? Why is that working like that? Why is the CHP not coming on? Why is the heat pump not charging that buffer vessel correctly? And unless you have somebody doing that kind of acceptance testing and agreeing that, you know, the past parameters with everybody involved, you will not get, you know, a fit for purpose heat network. You'll get what you're given, I'm afraid.
Yeah, absolutely.
Yeah.
And with for the procurement side of it, you get what you ask for, and if what you ask for is basic, then you'll get something basic. It's simple as that.
Why performance specs do the client and your tenant no good at all. It's a real cop out doing a performance spec because every project is completely different.
Really good, guys. Listen, thank you very much. Thanks very much for attending, all of those you out there as well. So the next time we'll be returning to, as I say, the Heat Vision 2030 project, taking a step back to look at a whole city heat network design, development and feasibility. And part of what we'll be looking at there is the policy framework required to make sure that these big heat networks thrive. In the meantime, once again, thanks very much for attending. Thanks to Stephen and Alistair for those insights. Our details were up there. If you wish to have further discussions, these guys can talk about heat networks till the cows come home. So yeah, it would be great to hear from you all. And in the meantime, take